This first video is on lesson 1.2, dimensional analysis. Now, dimensional analysis is something that you've covered in your math class previously, and it's also probably something that you've covered in your science class. It basically means converting from one measurement to another. And now here in the United States, we use a customary measurement system. We use things like feet, inches, ounces, pounds, weird stuff like that. But in other parts of the world, they use the metric system. And we need a way to convert from metric to our U.S. customary units. So here we have a table that tells us how we do these conversions. Now, as far as length goes, 1 metric meter is equal to approximately 3.28 feet. Now, this is rounded because there's a complicated calculation that goes along with that, but it's about 3.28 feet. And 1 centimeter is 0.39 inches, about. A square meter, which is area, is 10.76 square feet. A liter, which is volume, is about 0.26 gallons. And a kilogram, which is mass, or sometimes weight, is equal to about 2.2 pounds. So these are a table of our conversions from metric to customary units. Here we want to use the equivalent measures given in the table to find the capacity of an 8-liter gas tank in gallons. Now, if we look at the table, we know that 1 liter equals about 0.26 gallons. And I'm just taking that straight from that table value. So 1 liter is 0.26 gallons. Now, if we look at this diagram that they have set up for us here, they want us to find out about how many liters are in 1 gallon. Well, notice that our gallon is much bigger and our liters are kind of small. Now, these smaller squares, looks like about 4 of them will fit in 1 gallon. So we have about 4 liters in 1 gallon. There's definitely a decimal value there, but we're not gonna worry too much about that decimal value right now. Now, this next question says, will the number of gallons in an 8-liter gas tank be greater or less than 8? And we need to explain our answer. Well, check it out. We've got 8 liters right here in our diagram. Now, gallons are much bigger than these tiny liters. So it makes sense that not as many of these gallons are going to fit into this 8-liter tank. Because look, here we've got 1 gallon, and then we've got 2 gallons, and then we have a little bit of another one. So since the gallons are bigger, we need fewer of them. So will the number of gallons be greater or less than 8? It will be less, and that is because gallons are larger. So we need fewer to fill up the gas tank. All right. Now, this last part says, to convert 8 liters to gallons, do you need to multiply or divide by the conversion factor? And then they want us to actually carry out that calculation. Now, we have 8 liters, and we want to change it to gallons. And we know that 1 liter is 0.26 gallons. So if we take our 8 liters and we multiply it by our conversion, which is 0.26, so 8 times 0.26, that will get us 2.08. Now, if we take 8 and we divide by 0.26, that'll get us 30.77. Now, which one of these values makes the most sense? Well, remember here we said that we needed fewer gallons because the gallons are larger. If we multiply, we get a smaller number than 8. But if we divide, we get a bigger number, which makes sense. There are more of these in this 8 gallons. So in this case, we actually need to multiply by the conversion factor. And when we do that, we get 2.08 gallons. Now the next one says, how would you convert from 8 gallons to liters? Now if we had 8 gallons and we wanted to change it to liters, Gallons are bigger, liters are smaller, so we are going to have more of them to fit into the same amount of space. So in order to get a number larger than 8, which our liters would be, we would have to divide by the conversion factor. All right, next page. What this is leading us up to is converting measurements. Now, we use dimensional analysis to convert units by multiplying by these things called conversion factors. Now, this right here is a conversion factor. It is a fraction where the top and the bottom are equal, but they are in different units. So 12 inches and 1 foot are the same thing, but they have different units. These are conversion factors. And we always take our known amount and multiply it by some conversion factor. Here we have an example. It says the body of a large adult male contains about 12 pints of blood. Use dimensional analysis to convert this quantity to liters. There are about 2.1 pints in a liter. Okay, so the first thing we need to do is decide what are we given and what do we need to find. Now, we are given an amount of 12 pints of blood. That is our given. And we want to convert this quantity to liters. That is what they are asking us to do. They also give us a conversion factor. They say 2.1 pints equals 1 liter. 2.1 pints in a liter. So we have our given here, 12 pints of blood. Now we're going to put that over 1 because we can always put fractions over 1 and they're still the same. And we're going to multiply that by a conversion factor. We know 1 liter and 2.1 pints are equal. The way that they get this conversion factor is they say, okay, what is the unit on my given amount? And here, my given amount is pints. Since that is in the top in this fraction, I want it to be in the bottom in this fraction because then they cancel out. So 12 pints over 1 times 1 liter over 2.1 pints. Pints cancel out, and you're left with 12 times 1, which is 12 liters, and 1 times 2.1, which is 2.1. So 12 liters divided by 2.1. When we divide those two things, 12 divided by 2.1, we get about 5.7 liters. So the body of a large adult male contains approximately 5.7 liters of blood. They did have to round this amount just a little bit. All right, let's look at this next reflect question. It says, Elena wanted to convert 30 inches to centimeters. She multiplied 30 inches by 1 inch over 2.5 centimeters and got an answer of 12. What was her error? All right, well, we know that inches are bigger than centimeters, or rather centimeters that we're trying to get are smaller than inches, so there need to be more of them. But she got that there were actually less centimeters than inches in the same amount. Now, this is obviously wrong, and we want to find out what was her error. So what she did was she multiplied 30 inches over 1 times 1 inch over 2.5 centimeters. Now, I will tell you that 1 inch and 2.5 centimeters are about the same. The problem here is that when she multiplies inches times inches, 30 times 1 is 30, and when she multiplies inches times inches, she gets inches squared. So her inches are not canceling. 1 times 2.5 centimeters would be 2.5 centimeters. So instead of getting units in centimeters, she ended up with units of inches squared divided by centimeters, which are not the same thing. So her error was that she should have multiplied by 2.5 centimeters over 1 inch. All right, so I'm going to turn my paper sideways here, and I'm going to show you how that works out. So she wanted to convert 30 inches, which again, we put over 1, into centimeters. And we are told that 2.5 centimeters equals 1 inch. And that conversion is in your book if you ever need it. Now, I need to multiply by a conversion factor here. Since inches is in my numerator or the top of my fraction here, I have to put it in the bottom of my fraction here so that it cancels out. And then since I'm changing it to centimeters, I'll put centimeters on top. Now I know that 1 inch is equal to 2.5 centimeters. Here my inches cancel, and I have 30 times 2.5, which would give me 75, and then my units are centimeters, over 1 times 1, which is 1, and 75 divided by 1 is 75 centimeters. All right, now sometimes we need to convert not just one measurement, but measurements that are being divided, such as miles per hour or kilometers per second. When we do that, we usually have to use multiple conversion factors. We can't just use one conversion factor because we have multiple units. So here our example says, a cyclist travels 105 kilometers in 4.2 hours. Use dimensional analysis to convert the cyclist's speed to miles per minute. Write your answer with the correct number of significant digits and use 1 mile equals 1.61 kilometers. All right, so what we know, our given amount, is that he or she is traveling 105 kilometers in 4.2 hours. Okay, so I'm going to turn my paper sideways again so we can do this problem. So I've got 105 kilometers per every 4.2 hours. So I've got kilometers per 4.2 hours. All right, now what I want to change this to is miles per minute. So I want to change this to miles per minute. So I'm going to have to change kilometers to miles and then hours to minutes. So I'm going to work first with changing kilometers to miles. Now I know from that conversion factor they gave me before that 1 mile is 1.61 kilometers. Kilometers is on top and I'm wanting to get rid of it, so I'm going to put it down here, and I'm changing it to miles, so that's going to go up here. So let's see, 1 mile is 1.61 kilometers. Now that eliminates my kilometers, but I also have to change my hours to minutes. Hours is on bottom here, so I'm going to put it on top here, and then I'm changing it to minutes. Now I know that 1 hour is 60 minutes. Now that cancels out my hours. Then I simply multiply across the top, multiply across the bottom, and then I'm done. So 105 times 1 times 1 is 105, and my units are miles because that's all that's left here. And on the bottom I've got 4.2 times 1.61 times 60. Which is 405.72. Whoops, 405.72. And my units are minutes because that's all that's left. 105 divided by 405.72 gets me 0.26 miles per minute. So I converted from kilometers per 4.2 hours into miles per minute.